Let me tell you about something that keeps certain scientists awake at night, a discovery so unsettling, so profound in its implications, that it challenges our most basic assumptions about human uniqueness and our place in cosmic history. The evidence is mounting that something was here before us, not millions of years ago, not on some distant planet, here on Earth. An intelligent presence that rose, flourished, and vanished long before humanity took its first steps. This is scary. Not scary in the way of monsters or disasters. Scary in the way that forces you to reconsider everything you thought you knew about existence, about intelligence, about the fragility of civilizations and the silence that follows their collapse. Scary because if something was here before us, if intelligence arose on Earth before humanity, then we are not the first. And we may not be the last. And whatever happened to them could happen to us. I want to take you through the evidence, the theories, and the terrifying implications. Because this is not science fiction. This is a serious scientific hypothesis being investigated by serious researchers, and what they're finding is deeply disturbing. Let me start with the question that haunts this investigation. Earth is 4.5 billion years old. Life has existed here for at least 3.8 billion years. Complex multicellular life has existed for over 600 million years. Mammals have existed for over 200 million years. And yet, according to the conventional story, intelligence, technological civilization arose only once, only recently, only in us. Homo sapiens appeared about 300,000 years ago. We developed agriculture about 10,000 years ago. We industrialized about 200 years ago. In the vast sweep of Earth's history, human civilization is a momentary flash. If Earth's history were compressed into a single year, humanity would appear in the last few seconds before midnight on December 31st. Our technological civilization would occupy a fraction of a second. Is it really plausible that in 4.5 billion years, intelligence arose only once? That in all that time, across all those species, all those evolutionary experiments, only humans developed the capacity for technology, for civilization, for reshaping the world? Or is it possible, even likely, that we are not the first? This question has moved from philosophical speculation to active scientific investigation. And the answers emerging are not comforting. Now let me introduce the Silurian hypothesis. In 2018, astrophysicist Adam Frank and NASA climatologist Gavin Schmidt published a remarkable paper. They asked a simple but profound question. If an industrial civilization had existed on Earth millions of years ago, would we be able to detect it? They named their thought experiment the Silurian hypothesis after a fictional species of intelligent reptiles in the science fiction series Doctor Who. But despite the playful name, the paper was rigorously scientific. Frank and Schmidt examined what traces a civilization might leave in the geological record and what traces would be erased by time. The results were disturbing. Our own industrial civilization has existed for roughly 200 years. In that time, we have transformed the planet, burning fossil fuels, producing synthetic chemicals, altering atmospheric composition, triggering mass extinctions, covering vast areas with concrete and asphalt. These activities leave traces. Elevated carbon dioxide in ice cores, synthetic molecules in sediments, unusual extinction patterns in the fossil record, changes in isotope ratios, microplastics, radioactive fallout from nuclear testing. But what happens to these traces over millions of years? Geological processes are relentless. Continents drift, mountains rise and erode, ocean floors are subducted into the mantle, sediments are buried, compressed, transformed. Over tens of millions of years, much of what we leave behind would be destroyed, transformed, or buried beyond detection. Consider our cities. The great structures of human civilization, our buildings, our roads, our monuments, would be crushed, dissolved, and scattered by geological forces. Within a few million years, almost nothing recognizable would remain. Consider our plastic. Plastic seems eternal to us, but over millions of years it would break down, be buried, and eventually be transformed beyond recognition by heat and pressure. Consider our radioactive isotopes. Some would persist. Certain isotopes have half-lives of millions of years, but they would be dispersed, diluted, potentially indistinguishable from natural variation. Frankenschmidt concluded that detecting a civilization even a few million years old would be extremely difficult. A civilization 100 million years old during the age of dinosaurs would leave almost no direct trace. But almost no trace is not no trace. Certain signatures might persist. Now let me discuss what signatures we might look for. If an ancient civilization existed, what evidence might survive the geological processes that destroy most traces? The first signature is isotopic anomalies. Certain processes leave distinctive chemical fingerprints. Burning fossil fuels releases carbon with a specific isotope ratio, less carbon, 1,3, relative to carbon, 1,2. Nuclear activity produces specific isotopes that don't occur naturally. These signatures can persist in geological strata. If we found a layer of sediment from 100 million years ago with isotope ratios consistent with industrial activity, it would be powerful evidence. In fact, we do find such anomalies. At several points in Earth's history, the geological record shows rapid changes in carbon isotope ratios, changes that are difficult to explain by purely natural processes. The most famous is the Paleocene-Eocene thermal maximum, PETM, about 56 million years ago. In a geologically brief period, perhaps 20,000 years, enormous amounts of carbon were released into the atmosphere. Global temperatures spiked by 5 to 8 degrees Celsius. Ocean chemistry changed dramatically. Many species went extinct. What caused this massive carbon release? The standard explanation involves volcanic activity and methane releases from ocean sediments, but the speed and magnitude of the event remain puzzling. Some researchers have quietly noted that the isotopic signature is consistent with burning fossil fuels, though they hasten to add that this doesn't mean it was caused by burning fossil fuels. But it could have been. The second signature is extinction patterns. Our civilization is currently causing the 6th mass extinction in Earth's history. Species are disappearing at rates not seen since the dinosaurs died out 66 million years ago. If a previous civilization had similar impacts, we might see evidence in the fossil record. Sudden extinction events, especially affecting large animals, which technological civilizations tend to exploit first, followed by rapid recovery and diversification. Such patterns exist. The geological record contains several extinction events that are not fully explained by known natural causes. The end Permian extinction, 252 million years ago, killed 90% of all species, and its cause remains debated. The end Triassic extinction, 201 million years ago, similarly lacks a fully satisfying explanation. Could these extinction events have been caused or contributed to by ancient civilizations that exhausted their planet's resources before collapsing? We don't know, but we can't rule it out. The third signature is chemical anomalies. Our civilization produces synthetic chemicals that don't occur naturally, plastics, pesticides, industrial compounds. These break down over time, but some chemical signatures might persist. Certain geological layers show unusual concentrations of specific elements or compounds that are difficult to explain naturally. Heavy metal concentrations, unusual mineral formations, chemical deposits that don't fit standard geological models. Most of these have conventional explanations, or at least proposed conventional explanations. But some remain puzzling. The fourth signature is structural anomalies. Could physical artifacts survive millions of years of geological processing? Almost certainly not in recognizable form, but certain structures might leave traces. A massive underground facility, for instance, might create a void or density anomaly detectable by seismic surveys. A large mining operation might leave distinctive geological scars. An asteroid defense system that redirected an incoming impactor might leave a signature different from a natural impact. These are speculative, and no such anomalies have been definitively identified. But the search has barely begun. Now let me discuss why scientists find this hypothesis so disturbing. The Silurian hypothesis is not just an academic exercise. It forces us to confront uncomfortable truths about our own civilization and its likely fate. If a previous civilization existed and collapsed, what happened to them? The possibilities are not reassuring. They might have destroyed themselves through war, pollution, resource depletion, or some technology that proved more dangerous than they anticipated. This is exactly what many scientists fear humanity is doing right now. They might have been destroyed by a natural catastrophe, an asteroid impact, a supervolcanic eruption, a gamma ray burst. This reminds us that our own civilization is vulnerable to cosmic events we cannot prevent. They might have disappeared in some other way, transcended to a form we cannot detect, left Earth for space, or simply vanished through some process we cannot imagine. This is perhaps most disturbing of all because it suggests that even successful civilizations might leave no lasting trace. Whatever happened to them, the fact remains they are gone. If they existed, they are not here now. Their cities are dust. Their technologies are scattered atoms. Their great achievements are forgotten. Not a single undisputed trace of their existence has been identified. This is what awaits us, perhaps. In 100 million years, would any sign of human civilization remain? Would some future intelligence examining Earth's geological record be able to determine that we existed? Frankenschmidt's paper suggests the answer might be no, or at least detection would be extremely difficult. This is scary because it implies that civilizations are ephemeral. They rise, they flourish, they fall, and they vanish, leaving barely a ripple in the geological record. The cosmos might be littered with the graves of forgotten civilizations, and we would never know. Now let me explore the evidence for specific pre-human intelligence. The Silurian hypothesis is deliberately agnostic about what kind of civilization might have preceded us, but specific proposals have been made, and some are deeply unsettling. The first candidate is the dinosaurs. Dinosaurs dominated Earth for over 160 million years, far longer than mammals have existed and incomprehensibly longer than humans have existed. Some dinosaur lineages evolved sophisticated features, complex social behaviors, possible warm-bloodedness, and most intriguingly, large brains. The Troodontids were a family of dinosaurs with unusually large brains relative to body size. Some species had brain-to-body ratios approaching those of modern birds and mammals. They had binocular vision, grasping hands, and possibly sophisticated problem-solving abilities. Paleontologist Dale Russell famously speculated about what Troodontids might have evolved into if the asteroid hadn't ended the dinosaur age. He proposed a dinosauroid, a humanoid reptilian form with large brain, opposable thumbs, and upright posture. This was speculation, not a scientific claim. But it raised a serious question. If dinosaurs had another 66 million years, the time since their extinction, could they have developed intelligence, technology, civilization? We cannot know, but neither can we rule it out. And if they did, almost nothing would remain. The second candidate is even stranger: octopuses and their relatives. Cephalopods octopuses, squids, and cuttlefish have existed for over 500 million years. They have the most complex brains of any invertebrate. Octopuses use tools, solve problems, recognize individual humans, and display what appears to be curiosity and playfulness. But cephalopods are soft-bodied. They leave almost no fossils. If an intelligent cephalopod civilization had existed in the deep past, 500 million years ago, 300 million years ago, 100 million years ago, we would have no way of knowing. This is disturbing because it suggests that our search for pre-human intelligence might be fundamentally limited. We look for traces of technology, but technology as we understand it might not be the only path to intelligence. A marine civilization based on biological manipulation rather than metalworking would leave no trace we would recognize. The third candidate is genuinely frightening: unknown hominins. The human family tree is more complex than once thought. Over the past century, we have discovered numerous species of human relatives: Homo erectus, Homo neanderthalensis, Homo floresiensis, Homo naledi, denisovans, and others. Some of these species had large brains, used tools, and may have had language and culture. But our fossil record is fragmentary. We estimate that less than 1% of all the species that have ever lived have left fossils that we have discovered. Entire branches of the human family tree might have existed and vanished, leaving no trace. Could one of these unknown hominins have developed technological civilization millions of years ago, hundreds of thousands of years ago, and then collapsed? The conventional answer is no. We would see evidence, tools, structures, environmental changes. The absence of such evidence suggests no such civilization existed. But would we? Consider, if a civilization existed 2 million years ago and lasted for 10,000 years before collapsing, what evidence would remain? The tools would have rusted, rotted, or been crushed by geological processes. The structures would have been demolished by earthquakes, erosion, and vegetation. The environmental changes would have been overwritten by subsequent changes. We might have no evidence because the evidence was destroyed, not because the civilization never existed. Now let me introduce the truly terrifying possibility. What if something was here before us, and what if it wasn't from Earth? The Earth has been bombarded by asteroids and comets throughout its history. Some of these impacts have been devastating. The Chicxulub impact that killed the dinosaurs, for instance, released energy equivalent to billions of nuclear weapons. But impacts also deliver material from elsewhere in the solar system. Rocks from Mars have been found on Earth, blasted off the Martian surface by impacts and eventually landing here. It's theoretically possible that life, or even evidence of intelligent activity, could be transferred between planets this way. What if, billions of years ago, an intelligent civilization existed elsewhere in the solar system on Mars, perhaps, or on a moon of Jupiter or Saturn, and some trace of their existence was transferred to Earth? Mars, in particular, is intriguing. Mars was once warm and wet, with conditions potentially suitable for life. Today it is a frozen desert, but billions of years ago it might have supported complex life, even intelligent life. If Martian civilization existed and collapsed, or if its inhabitants deliberately seeded Earth with life or messages, traces might remain here, buried in ancient rocks, waiting to be discovered. This is highly speculative, but it cannot be ruled out. And some scientists find the possibility genuinely horrifying because it implies that intelligence is not rare, but that intelligent civilizations routinely destroy themselves or are destroyed, leaving barely a trace of their existence. Now let me discuss what scientists are actually doing to investigate these possibilities. The Silurian hypothesis has moved beyond thought experiment to active research. Scientists are developing methods to search for evidence of pre-human industrial activity. The first approach is refined analysis of geological strata. Researchers are examining ancient rock layers with new precision, looking for isotopic anomalies, unusual chemical concentrations, and other signatures that might indicate industrial activity. The PETM, mentioned earlier, is receiving particular attention. Its rapid carbon release remains incompletely explained. The second approach is analysis of mass extinction events. Scientists are re-examining the causes of mass extinctions, considering whether any might have been caused or accelerated by industrial activity. The traditional explanations, asteroid impacts, volcanic eruptions, climate change, remain dominant, but researchers are looking for anomalies that might suggest other factors. The third approach is searches for artifacts. Some researchers are looking for physical artifacts that might have survived in geological formations, in ancient sediments, even in lunar samples. The Moon, with no geological activity to destroy evidence, might preserve traces of ancient civilizations better than Earth. If a previous civilization developed space technology, artifacts might remain on the lunar surface. The fourth approach is simulation and modeling. Scientists are modeling what traces our own civilization would leave over millions of years, then using these models to predict what traces an ancient civilization might have left. This helps focus the search, identifying which signatures would persist longest and be most detectable. Now let me explore the connection to the Fermi paradox. The Fermi paradox asks, if the universe is vast and old, where is everyone? If intelligent civilizations arise routinely, why haven't we detected any sign of them? The Silurian hypothesis offers a disturbing answer. Perhaps civilizations routinely arise and collapse, leaving no lasting trace. Perhaps the galaxy is filled not with thriving civilizations, but with the invisible graves of civilizations that rose and fell, leaving nothing behind. This is called the Great Filter hypothesis. At some point in the development of intelligent life, there might be a filter, a challenge, so difficult that almost no civilization survives it. If the Great Filter is in our past, if the hard part was the evolution of life, or the evolution of complex cells, or the evolution of intelligence, then we have already passed it. We might be rare, but we are survivors. If the Great Filter is in our future, if the hard part is surviving technology, or avoiding self-destruction, or some challenge we cannot yet imagine, then we are doomed. Like all the civilizations before us, we will rise, flourish, and fall, leaving barely a trace. The possibility that something was here before us and is now gone suggests the Great Filter might be real. Something destroyed them, or they destroyed themselves. And whatever it was, it might await us too. This is why scientists are horrified. Not because they have found definitive evidence of a previous civilization, but because the possibility exists and because the implications are so disturbing. Now let me discuss the psychological impact of this hypothesis. The possibility that we are not the first intelligent species on Earth challenges deep-seated human assumptions. We have always believed we were special, the pinnacle of evolution, the culmination of 4.5 billion years of cosmic and biological development, the only beings capable of asking why we exist and what it all means. If something was here before us, this specialness dissolves. We are not the culmination, but one episode in a potentially long series. We are not unique, but typical. Whatever we achieve, others may have achieved before and lost. This is psychologically devastating for many people. Our sense of cosmic significance, already challenged by Copernicus, Darwin, and modern cosmology, receives another blow. We are not the center of the universe. We are not the purpose of evolution. We may not even be the first intelligent beings on our own planet. But there is another psychological response: humility. If we are not the first, then we have something to learn from those who came before, even if we can only learn from their absence, from the traces they didn't leave, from the fact of their disappearance. What did they do wrong? How can we avoid the same fate? What must we do differently to become a civilization that persists, that leaves traces, that is remembered? These are not abstract questions. They are urgent. If the hypothesis is correct, the clock is ticking for us as it ticked for them. We have centuries, maybe millennia, to solve the problems that destroyed them, or we will join them in oblivion. In part 2, I want to explore specific evidence that has been discovered, anomalies in the geological record, unexplained phenomena, and hints that something might have been here before us. The evidence is not conclusive, but it is deeply unsettling. So we've established the theoretical framework, the Silurian hypothesis, the challenges of detecting ancient civilizations, the disturbing implications for our own future. We've seen why scientists take this possibility seriously and why they find it so unsettling. Now I want to examine the actual evidence, the anomalies in the geological record, the unexplained phenomena, the hints tantalizing, ambiguous, but deeply troubling that something might have been here before us, because this is where the hypothesis moves from thought experiment to disturbing reality. The geological record contains things that shouldn't be there, events that don't fit standard explanations, patterns that raise uncomfortable questions. Let me take you through what we found. Let me start with the Paleocene-Eocene thermal maximum. The PETM, as it's known, occurred approximately 56 million years ago. It represents one of the most dramatic climate events in Earth's history and one of the most mysterious. In a geologically brief period, perhaps 20,000 years, possibly as little as a few thousand, enormous quantities of carbon were released into the atmosphere. Global temperatures spiked by 5 to 8 degrees Celsius. Ocean chemistry changed dramatically. Deep ocean waters became acidic and oxygen depleted. Many species went extinct. The standard explanation involves a cascade of natural processes. Volcanic activity might have triggered the initial warming. This warming might have destabilized methane hydrates, frozen methane deposits on the ocean floor, releasing vast quantities of additional carbon. The system spiraled into a hothouse state. This explanation is plausible, but it has problems. The speed of the carbon release is difficult to explain through natural processes alone. The isotopic signature, the specific ratio of carbon isotopes, is consistent with burning organic matter, not just releasing methane. The amount of carbon released rivals what humanity might release if we burned all available fossil fuels. Some researchers have noted, carefully and with appropriate caveats, that the PETM isotopic signature is consistent with industrial combustion of fossil fuels. They are not claiming that an ancient civilization caused the PETM. They are noting that the signature is ambiguous, that we cannot definitively rule out a non-natural cause. This is unsettling. 56 million years ago, something released enormous quantities of carbon into the atmosphere in a geologically brief period, with an isotopic signature consistent with burning fossil fuels. The standard explanation is natural processes. But the standard explanation is not airtight. What if it wasn't natural? Now let me examine another anomaly, the end Permian extinction. 252 million years ago, Earth experienced the most devastating mass extinction in its history. Over 90% of all marine species and 70% of terrestrial species went extinct. It was the closest life has ever come to total annihilation. The standard explanation involves massive volcanic eruptions, the Siberian traps, one of the largest volcanic events in Earth's history. These eruptions released enormous quantities of carbon dioxide, methane, and toxic gases. the climate destabilized, oceans became acidic and anoxic, life collapsed. This explanation is well supported. The timing of the Siberian traps matches the extinction. The scale of the volcanic activity matches the scale of the catastrophe. But some aspects remain puzzling. The extinction occurred in pulses, not a single event. There appear to have been multiple waves of dying, separated by intervals of partial recovery. This pattern is difficult to explain through volcanic activity alone. The recovery took extraordinarily long, perhaps 10 million years, before biodiversity returned to pre-extinction levels. This is far longer than other mass extinctions, even those of similar magnitude. Something prevented normal recovery processes. Some researchers have proposed additional factors, a massive asteroid impact coinciding with the volcanism, or a cascade of environmental changes that reinforced each other. But these explanations remain incomplete. What if the pulses of extinction reflect not natural cycles, but the rise and fall of something? What if the prolonged recovery reflects not natural slowness, but the lingering effects of something that was done to the planet? I'm not claiming this is what happened. I'm noting that the standard explanation leaves questions unanswered, questions that alternative hypotheses might address. Now let me discuss the Ordovician Silurian extinction. About 445 million years ago, Earth experienced another major extinction event, the second most severe in terms of general loss. An estimated 85% of marine species went extinct. The standard explanation involves glaciation. A sudden ice age gripped the planet, locking up water and ice sheets, dropping sea levels, and disrupting marine ecosystems. When the ice age ended, sea levels rose rapidly, creating further disruption. But the cause of this sudden glaciation remains debated. Some researchers propose changes in atmospheric carbon dioxide, perhaps caused by the rise of land plants or by weathering of newly exposed rock. Others propose changes in ocean circulation. Others propose extraterrestrial factors, a gamma ray burst or dust cloud affecting Earth's climate. None of these explanations is fully satisfactory. The glaciation appears to have begun and ended abruptly, faster than most proposed mechanisms can explain. What if the glaciation was not natural? What if some activity removed carbon dioxide from the atmosphere, deliberately geoengineering on a planetary scale, and then stopped, allowing the climate to recover? What if the extinction was collateral damage from someone else's climate intervention? This is speculation, but the event remains poorly explained, and alternative explanations deserve consideration. Now let me examine some specific physical anomalies. The geological record contains objects and formations that are difficult to explain through known natural processes. Most of these have conventional explanations, or at least proposed conventional explanations, but some remain genuinely puzzling. The first example is the Antikythera mechanism. This is not a geological anomaly, it's an archaeological one. But it illustrates how easily advanced technology can be lost and forgotten. The Antikythera mechanism was discovered in a Greek shipwreck in 1901. It dates to approximately 100 BCE. It's a complex mechanical computer capable of predicting astronomical positions, eclipses, and even the timing of the Olympic Games. For decades after its discovery, scholars refused to believe it was genuine. The technology was too advanced. Nothing comparable was known from the ancient world. It seemed impossible. We now know it was real. The ancient Greeks had developed sophisticated mechanical technology that was subsequently lost. For over 1,000 years, humanity forgot how to build such devices. The knowledge vanished, only to be rediscovered centuries later. If complex technology can be forgotten within historical times, what might have been forgotten over geological time? What might have existed millions of years ago and vanished completely? The second example involves anomalous metallic objects. Over the years, various claims have been made about metallic objects found in ancient rock formations.